Namaskar, good morning. This is Engineer Suraj Singh, Civil Engineers and Earthquake Management. Earthquake, very natural phenomenon and also a common phenomenon. All over the world, it happens and it should be taken care of. How care can be taken? Because due to earthquakes are very expensive, life is lost, money is lost, material is lost, and it's all natural loss. We have to mitigate it. Mitigation means preventive measures. How to prevent the structures from the damage or from the disaster caused by the earthquake. This is the responsibility of civil engineers, or you can say structural engineers, construction engineers, and many other classes of engineers. Let us start with discussion of civil engineers. Civil engineer, which is a gross term, includes civil design engineers, civil surveying engineers, civil soil engineers, and civil construction engineers. To start the concept of a building, it is the role of the design engineer who produces on a piece of paper using computer software or anything how the building structure has to be done. At that time, it's very important for the structural design engineer to conceive what he wants or what she wants. It's not simply analysis of structure or arrangements of steel reinforcement or structural steel members. It has to know where the building is going to exist and what is the zone in that area. After knowing this, it has to be known to what extent seismic force shall be impacted on the building. The job of the structural engineer starts there, and he has to take into consideration all aspects of the earthquake forces from the foundations to the top of the building. And he has to also understand and know and emphasize that foundation has to be compatible with the nature of the soil in that area or where the building is sited. He has to demand and request a soil report from any material testing laboratory generally, and a soil investigation has to be conducted. Structural engineer has to advise the laboratory what type of reports, what parameters the soil report are required to meet the design standards and design specifications. All the tests shall be or have to be conducted by the soil material testing laboratory based on that request. The tests are exploratory and all the information are to be collected on those tests. Based on those field information as well as laboratory tests, soil engineer or soil or geotechnical engineer would comprise the report giving summary of what the tests were and what these tests indicate and what type of foundation is suitable for that area. The recommendations have to be studied thoroughly by the design engineer. After having gone through those recommendations and have properly understood the effects of the soil on the possible foundation, foundation decisions are to be taken. These are all detailed decisions, and based on those parameters, foundations are to be decided. This is very important aspect. Similarly, design engineer has to work on analysis of the frame or analysis of whatever aspect of building is in mind of the engineer. All the forces are to be computed in, and he has to prepare the detailed designs, detailings correctly, duly communicated on the detailed drawings, shop drawings, and these have to be finally sealed after approval given to the site engineer or the construction engineer or the project manager or project engineer, whatever the designation. One more thing design engineer has to ensure before taking final concepts of the design. The design should be reasonable. It should be having a good concept, keeping in view the market material availability, skill reward availability, homework methods availability, type of people or skilled craftsmen available. All these factors, though not relevant to the design aspect, must be kept in mind to make a manageable design. We can call it a constructible design. Construction is going to be done based on those times, and if the site engineer finds problems in the construction of the building or the structure, there is no meaning of that design if it cannot be carried out comfortably with ease and with economy and within the indicated or within the contract time, duration. If you have to spend a lot of money on that, let's use that design. Design should be comfortable, economical, and requires least wastage of material and provides least comfort to site engineer and the project. If it is easily workable, I can say the design is class 1. You can say very nice, very good. But it really happens. I have seen in my career that design drawings are very attractive, very much detailed, and it takes a lot of time to understand the design. So many complexities are inducted into the design that every, everything is lost. Means the engineer has to concentrate on the site, on the drawings, and then understand. After that, he has to find the incompatibilities or clashes between architectural drawings and structural drawings and many other services drawings, based on which study the questions are raised to the design engineer, who then studies on them further, after which he gives further solutions or clears the clashes. This cycle takes many hours of all concerned and adds to the sheer wastage of the project time. This fact is very important for a design engineer to understand that before designing anything, any member or any structure, constructability aspect must be considered thoroughly. And design engineer can do that provided he has plenty of experience on site management. Direct induced structural engineer would definitely add problems in the design which have to be corrected and resolved. Well, I don't mean to criticize anybody, but facts remain, and structural engineers should take into their consideration all these aspects to help the project move smoothly, keep in budget, and should not waste any day of construction on site. Site engineers, after getting the drawing with them and specifications from the designer, should also deeply study all the process of the design, all the pages of structural engineering, all drawing specifications before taking any executive decision. This is very important factor, and I can call this process as design and specification review. In case site engineer discovers that ambiguities or some clash or some deficiencies or any other thing out of those documents, it is his duty to consult the site engineer for their clarifications or for resolutions. That is the first part of site engineer ever to resolve or to do, without which he cannot successfully do his job. This is very important. The site engineer's basic job is to start with caution. After that, he has to see drawings thoroughly, specifications thoroughly, understand them, and then start planning the execution schedule with other engineers. Well, time is limited. Thank you very much for your kind attention. With regards, this is Suraj Singh. Thanks.